Hi everyone, we're going to apply the mean value theorem to an example where we have a polynomial and it's defined on a interval from 0 to 2. It's a closed interval because it includes its endpoints. And we're going to show that f satisfies the hypothesis of the mean value theorem, and then we're going to find all values of c that satisfy the conclusion of the mean value theorem. So the hypothesis is first that f is continuous on the closed interval where it's defined, and that's in this case between x is greater than or equal to 0, less than or equal to 2. And the other piece for the hypothesis is that f is differentiable on 0, 2. And this is because f is a polynomial. That's a theorem that's in beginning calculus books, but you could also say, it is an elementary function. So that would include all the trig functions, logarithm, root functions, exponential functions. Elementary functions are continuous on their domain. Inverse trig functions. I say logarithm. They're continuous on their domain. These elementary functions. It's a question, what's an elementary function? But anyway, polynomials are continuous on a closed interval and differentiable on the open interval, and that's true for the so-called elementary functions. But anyway, okay. So we have this as a polynomial. Now let's get to the conclusion. The conclusion is there is a number c between these guys 0 and 2. Okay, so this is right here, a equals 0, b equals 2, such that f prime of c is equal to f of b minus f of a over b minus a. So for our case, again, that a is equal to 0 and b is 2, so it's f of 2 minus f of 0 over 2 minus 0. All right, so what I'm going to do is I'm going to break this into pieces just to try to manage this better. I'll call this the left-hand side, and this is the right-hand side. LHS, RHS means left-hand side, right-hand side. So I'll do the RHS, right-hand side, and I'll just start working on that. F of 2 minus f of 0 divided by 2 minus 0 is equal to what? Well, we have f given above here. It's a little bit long. Okay, so I'm going to put parentheses. Oh, the denominator is the easy part. 2 minus 0 is just 2. Okay, so I'm going to look at this guy right here. And wherever I see x, I'll put in 2. And then I'll look at the same thing. Wherever I see x, I'll put in 0. So I'm going to put 2 and I'm going to put in 0. So 0 cubed plus 0 minus 1. 2 cubed minus 2 minus 1. Okay, so let's just see if I can do this without a calculator. 2 to the third is 8 plus 2 minus 1 minus, well, 0 cubed 0, 0, 0, so minus 1. So it's minus a negative 1 all over 2. So this is this guy right, well, this 8 plus 2 is 10, minus 1 is 9. This makes, well, anyway, okay, so this makes 9 plus 1 over 2, which is 10 over 2, which is equal to 5. Okay, that's the left-hand side. That's what that means. What I'm saying is that this stuff on the right-hand side, sorry, that's the right-hand side. All this stuff on the right-hand side, that's equal to 5. And what we're going to do is we're going to take the derivative and set it equal to the right-hand side, which is 5, and solve. It's really a lot like finding critical numbers. Where critical numbers, you take the derivative and set it equal to 0. Here, we're going to take the derivative and set it equal to 5, and then we'll solve. So let's go ahead and LHS, the left-hand side. And so to do that, we're going to find f prime of x. Okay, so again, I need what f of x is. F of x equals x cubed plus x minus 1. The derivative is 3x squared plus 1. Now, okay, so now I'm going to, do this next step, solve the left-hand side equals the right-hand side. The notation, maybe don't want to write LHS, write RHS. It's pretty common in math that it's used like that. They do that though, LHS, right, and so forth. So, okay, so I wrote f of x, f prime of x, but what I want is, okay, so I want f prime of c is equal to this f of b minus f of a over b minus a, where again, b is equal to 2, a is equal to 0. Okay, so for this guy, f prime of x, or f prime of c, I'm going to put c where I see x. And on the right-hand side, I'll put in 5. Now, sometimes I just leave it as x, because I'm used to solving things with x, but oh well. Okay, now this is a quadratic, but it's a quadratic that has a square and a constant. So typically you just set c squared equal to a number and then solve. You don't need to do factoring. And then c is equal to, be careful, plus or minus the square root of 4/3, which is equal to plus or minus the square root of the numerator is 2, the denominator 3. Some people say, well, I don't really need to rationalize the denominator, but that's sort of a new thing. We used to, when I was a kid, we always had to rationalize the denominator. That was a long time ago when I was a kid. Okay. Another thing is we're only looking in the interval from 0 to 2. So even though I dutifully did plus or minus the square root of 4/3 because I'm supposed to do that, we only are going to use only c equals 2 over radical 3 is in the interval from 0 to 2. So don't do the negative one. So c is equal to, I don't know, it's up to you whether you feel like you have to rationalize the denominators. Certainly we should know how to rationalize the denominator. That's another topic, but you can do a little aside. If you just, it's like an algebra 1 video. Aside, 2 over rad 3 you multiply is equal to 2 over rad 3, and you multiply the numerator denominator rad 3. Why am I wasting everybody's time on this? So this is sort of silly. Okay. Anyway, 2 rad 3 over 3. So either one, we have, those are the same. These are equal to each other. So, all right, you see this in almost every single beginning, this example in almost every single beginning calculus book. All right, thank you. Goodbye.